Hey guys, this is Chayon and today I'm gonna solve another 2000 plus DP problem. This problem is also very beautiful. I also shared this spreadsheet with you where you can find the link of all the problems and the link of the videos. Feel free to make a copy out of that. In here in files you can make a copy easily for yourself and edit that version for yourself. And whenever you solve the problem you can simply just write solved in front of it and then every number will be updated. So let's take a look at the problem today, 777E Hanoi factory. This problem says that assume that we have n rings and n is up to 10 to the 5th, and each ring has an inner radius and an outer radius. The inner radius of ring number I is AI, the outer radius of ring number I is BI. And also each ring has a height, and height of ring number I is HI. You want to place these rings on top of each other such that ring number J can come to the top of, can be on top of ring number I if and only if this happens. First of all, B of J should be less than or equal to B of I. So the outer radius of ring number J should be smaller than or equal to ring number I. So you can put a ring on top of another one if it is small, if outer radius is smaller. Also, the outer radius of J should be greater than the inner radius of ring number I, so that it doesn't fall completely inside a ring number I. Okay, so B of J, the outer radius of ring number J should be between B of I and A of I. It should be greater than A of I and less than or equal to B of I. So it's like it should be in this interval. And you put all these rings on top of each other, you want that the sum of the heights will be maximum possible. You need to say that what is that maximum possible height. Pause the video, think about this problem as much as you can. Whenever you were stuck, continue the video. Okay, first let's talk about sum of n squared solution. We can just say that initially source all the rings by their value of b in descending order. So sort them by value of b in descending order, and in case two of them had the same value of b, compare them by their a. The one with greater a comes first. So it's like we sort them in according to pair of b of I and a of I in descending order. If b of two rings were different, the one with greater b comes first. If b was equal, the one with greater a comes first. Okay, so b is the first priority, the outer radius. So now if we consider these rings, we can say that dp of I is equal to the maximum possible height if we only consider if ring number I is the last ring that will be in top. Well, we know that ring number I can be on top of all the rings before it. So I can just have a 4 on all of them, and for each j, if it could be on top of ring J, we can just say that dp of I max equal to dp of J plus 1. Max equal to is not really an operation in C++, I just use it for explanation. So if that happened, if I could be on top of J, we just say that dp of I max equal to dp of J plus 1. Or sorry, it's not plus 1, plus h of I. Because each of them have some heights, and when it can be on top of that one, we should add its heights. And why does it work? The only thing that can bother us a little bit is the case where some b's are equal. Well, in that case, I said that the one with the least value of AI comes last. So it's like if we have several rings with the same outer radius, we can just say that the one with least inner radius comes last and comes to the top of the others. This way, it is better for future, because if the one with greater inner radius comes later, then it is harder for the next rings because they need to be greater than this inner radius. But if they come after this one, they need to be greater than their outer radius should be greater than this one. So it's better if this one is on top rather than this one. Okay, so I'm saying that if two rings have the same outer radiuses, the one with the least inner radius is better to be on top. And that's why I want it to come after, so that it will be on top, and that inner radius that is smaller will be the inner radius for the next rings. That's why I wanted the one with the least value of inner radius comes last. And also you could also say this, the issue with equal bi's could be also resolved like this. If you had several values of b which were the same, if you had several same b values, you can just merge them all. You can just merge them all. If, for example, b of I is equal to b of j, you can just make another one and another ring instead of them. For example, this is b of I and a of I, b of j and a of j. And both of them have some heights, h of I and h of j. We can just, instead of it, make another ring that has the exact same outer radius. It has the minimum inner radius of these two, because we can put the minimum one on top, and then the next one should be greater than or equal to minimum. And we can just add their heights. So we can just put the smaller one on top of the other one and merge these two this way. This way we can also merge all the ones with the same outer radiuses, and we do not need to deal with the ones with different inner radiuses anymore. With the same outer radiuses anymore. And then all of them are different, and then we just sort them in descending order by the value of b. So this way we have an O of n squared solution. Now try to improve it to a better time complexity. Think about it and then continue this video. Well, there is an important fact that you can use to make this problem easier for yourself. You can just say that if you sort the rings in the order that I said, and assume that we don't have equal values of b's anymore. As I said, we can merge them initially, and we do not have equal values of b anymore. We also showed that if you sort them, as I said, we just sort that by their second, and if they were equal, sort them by their first in descending order. That would also work. But for now, let's assume that all the b's are different. Then we can say that if we have some I, ring number I, that can be on top of ring number j, and it also can be on top of ring number k. So I can both be on top of ring number j and can be on top of ring number k. Then I'm saying that it's always best for I to be on top of ring number j. And I'm saying that dp of I will be equal to dp of j plus hi for the greatest possible j. So for I, it's the best to be after the last possible ring that I can be on top of that. Try to prove this fact. Okay, how do we prove this? Because I can be on top of j, we know that b of I is in this interval. B of I is in the interval of a of j to b of j. Right? And also we know that b of I can be on top of k. So also b of I is in this interval. A of k to b of k. Well, it's obvious that b of I is less than these values because it comes after them, and we sorted everything according to b, in descending order by b. So we're sure about that. But the important thing is that j also comes after k. So we are sure that b of j is less than b of k too. We are sure about that. Now what we can say is that b of j, we know that b of j is greater than or equal to, or because we said that we do not have equal values of b anymore, just greater than b of I. And also b of I, based on this, is greater than a of k. So b of I is greater than a of k as well. Therefore, we know that b of j is greater than a of k. So b of j is between a of k and b of k. Therefore, j can be on top of k. So all I'm saying is that if b of I is in this range and also in this range, then it means that b of j is greater than a of k. Because b of I is greater than a of k, and it's also less than or equal to, or less than b of j. Therefore, a of k is less than b of j, and therefore it can be on top of the other one, right? Even if we would sort them by their b and we had duplicated values of b's, then this was greater than or equal to, and then again it could be on top of that one as well. And the same thing would happen as well. Just we needed to be worried about the order of putting the rings with the same outer radiuses on top of each other. And because we know that it's always the best to put the minimum above all the others, if we sort them by their A in descending order, that would also be resolved as well. So we could also just not merge and just sort everything as I said. We just sort everything by the pair of B of I and A of I in descending order. Okay, so I proved that we can always say that I should come on top of the last possible j that it can be on top of it. Why? Because if I can be on top of j and I can be also on top of k, it's not optimal to put I on top of k, because we can put it on top of j and then put j on top of k. This way our answer will be increased, because j is also included this way. When we can also include j, then why not? We will include it if we can include it. So I will be on top of j and j will be on top of k instead of putting I on top of k. So now our question will be this: for each I, we need to find the latest possible j such that I can be on top of j. We want to find the latest one. Now think about this problem. How can we find that latest one and set dp of I equal to dp of j plus h of I? Think about it, and whenever you are stuck, continue this video. As a hint, I tell you to think about the stack. Do not forget that if I cannot be put on top of another ring, if there's some ring, we know that b of I is less than b of j for each of the previous ones. So if it cannot be put on top of the other one, it means that b of I is also less than or equal to a of j. This happens that it doesn't let you to put it on top of the other one. And because b's are in descending order, when it happens, it's impossible to put any ring on top of that ring. When you cannot put ring number I on top of ring j, then you cannot put any other ring on top of that, because for all the next ones, we know that b of k is less than b of I, because they come after this one. So outer radiuses will be kept decreasing. So if this one cannot come on top of j, the next ones also cannot come on top of j. Don't forget that, and try to use this fact and just use a stack to solve this problem. Think a little bit more about this, and then I will tell you the full solution. I'm just saying that we can use some stack and keep all the candidates on it, all the possible candidates that this new ring can be on top of. We know that we want to always put a ring on top of the last possible ring. Well, we start from this stack. We see each one of them. These are all the possible candidates. Okay, these are all the ones that can possibly be the last ring that this ring can be on top of them. This is ring number I, and it can be on top of each one of these rings. These are the candidates. Well, first I say that I compare it with top of my stack. For example, assume that j is at top of my stack. If I can be on top of j, then we have found our j. Otherwise, it means that b of I is less than a of j, less than or equal to a of j. So I cannot be on top of j. Therefore, all the other elements also cannot be on top of j as well. So j is not a candidate anymore. You can simply remove j. Because when I cannot be on top of j, about b's we are sure that b of I is less than or equal to b of j. So that there's no issue there. So if I cannot be on top of it, it means that b of I is less than or equal to a of j. So this ring cannot be on top of j. So all the other rings cannot be on top of j as well. So we can easily remove that from our candidates and keep doing that until we reach somewhere that I can be on top of it. Well, because these were only our candidates, all the other elements which are removed cannot be our answer. This will be our answer. this will be the one that I can be on top of it. And then we just say that dp of I is equal to dp of this one plus h of I, and put this one in our stack as well. And that's going to be all about our answer. And this way our total order will be O of n. So this way we can solve this problem in O of n. So now let's try implementing it. Well, we have n up to 10 to the 5th and ai's, bi's, and hi's in order. So we have const int of n, an. Okay, initially we just need to see in everything I less than n, I plus plus. We just seen ai, bi, and hi. Now we need to sort everything. I use an additional array, ord. First I put all the indices and I just sort these indices. I said iota ord plus n 0. It just puts number from 0 to n in ord. 0, 1, 2, 2, n minus 1 in ord, in the first n elements of ord. Iota is like this. You give it the first number and it keeps increasing that number by 1 and puts that in ord. And then sorts ord plus n cmp. And cmp is like this, inline bool of cmp. You have int of I, int of j, and you can just say that return pair of pii is pair of int and int. I used it as pair of int and int. Pii, as I said, b of I and a of I, pair of this, should be greater than pii of b of j and a of j. So it means that the one that comes first should have greater value of b or the same value of b and the greater value of a. Okay, either one of these two should happen. So we sort them like this, and then we have a 4 from 0 to n. And as I said, we also have a stack. And let me also define my dp. We have some stack of int. Stack can also be implemented with an array. I just in here use stack itself because it might be easier to understand, but it can also be implemented with an array. I usually myself also use an array for this, but let's just use a stack in here. And then I say that while st.size and. Well, first let me say that the index of this new one, let me change this to t. The ring that we're talking about right now, the ring that we will work with right now, is ord of t. Because we sorted everything in ord, we know them in the sorted order. So the ring number I that we work with is ord of t, the one that is at place t in my orders. I say that while st.size and we should say that a of st.top should be less than, should be strictly less than b of I. This should happen. So if it does not happen, if it is like this, a of st.top was greater than or equal to b of I, then it means that this one is not useful for us. So we can just simply say that st.pop. So while this happens, we just pop it because we know that this one is not a candidate anymore. This is not even good for the others. But once we stop, we can say that if st.size, it means that we have someone. Then we can say that dp of I is equal to dp of st.top plus hi. Otherwise, dp of I is just equal to hi because it cannot be on top of anything if stack is empty. And then we can say that st.push I itself. So do not forget that I is according to my order. I will go on these orders and then I update my DPs. I just say that while st.size and a of st.top was greater or equal to bi, then st.top is not a candidate anymore. We just st.pop. Then if st.size was not 0, then we say that dp of I is equal to dp of st.top plus hi. Otherwise, dp of I is equal to hi, and then st.push I. And at the end, we just need to know the maximum possible dp. And the answer can also be long. So we say that long of ans equal to 0. Definitely my DP should be long as well. I just use LL as long. Let me also write LL. I just use LL as long. So this is my DP, and it should be long. Other things do not need to be long because they can all fit into it. And then in here, I just need to say ans equals to maximum of ans and dp of I, and then I just see out ans. And that is gonna be my final answer. So let me compile this one and see if this one works. Okay, awesome. I haven't defined n. It's awesome. 6 works, 4 works. So let me submit and see what happens. Test 10. Okay, accepted. So this was a very beautiful problem because it had many theoretical facts. So sometimes in DP problems you have to prove many theoretical facts to find your answer. I hope you have enjoyed it. I will see you in the next videos. You can see the link of this problem and the spreadsheet in the descriptions below. See you in the next video. Shaya.